Hi, my name is Dr. Jarrod Harman. I'm a recent graduate from Louisiana State University Health Sciences Center in New Orleans and will soon be starting my postdoctoral fellowship at Boston Children's Hospital, Harvard School of Medicine, in the Department of Ophthalmology in the laboratory of Dr. Kira Fu. My work is focused on glaucoma and the related ischemic retinopathies such as diabetic retinopathy. We use a non-invasive therapeutic technique known as preconditioning to induce neuroprotection in the retina and central nervous system and are interested in understanding the adaptive epigenetic remodeling that results with our therapy. When considering visual disorders, glaucoma and diabetic retinopathy represent two of the greatest health and economic burdens on the U.S. economy and are leading causes of irreversible vision loss worldwide. Glaucoma currently costs the U.S. healthcare system about $3 billion annually, while the CDC projects the visual disorders to exceed $700 billion by the year 2050. Currently, there are over 3 million Americans and 75 million people globally that are living with glaucoma. As of 2021, over 500 million people are living with diabetes, and 3 out of 4 of those individuals will develop ocular pathologies after living with diabetes for 15 years. Moreover, Latina, Hispanic, and African American populations are disproportionately affected by these diseases. Age, sex, genetic background, and comorbidities such as diabetes and hypertension are considered risk factors for these diseases. Early treatment modalities are focused on managing intraocular pressure or managing the metabolic dysregulation of diabetes, but efficacious therapies related to neuroprotection are still scarce. For these reasons, we have adopted a multifaceted approach to investigating the retinal structure, function, metabolism, proteome, and epigenetic changes that occur in our adaptive models of preconditioning. During my tenure at LSU HSC, I was mentored by Dr. Jeff Gaudet, who specializes in epigenetics and preconditioning of the central nervous system. Dr. Gaudet's previous work has demonstrated that repetitive hypoxic conditioning can induce long-lasting neuroprotection in the brain and the retina. The goal of my dissertation work was to test the hypothesis that by extending the duration of preconditioning, we can also extend the duration of the protected therapeutic windows. In fact, we were able to demonstrate resilience against retinal ischemia in the untreated next-generation offspring. As we are entering the era of personalized medicine, we have made it a point to focus on using both male and female, inbred and outbred mouse models to explore further the biological roles that sex and genetic background play in ocular disease progression. The ongoing work is focused on identifying the specific molecules and molecular pathways involved to eventually develop pharmacological targets that may serve to translate this therapy clinically. This work is incredibly important because many of the wonderful people in the great state of Louisiana are affected by one or more comorbidities that potentially make them high risk for developing one of these diseases. And there's no doubt that the folks on Capitol Hill have had an incredibly difficult last 2 years. I would like to end by acknowledging your efforts and thanking you for your continued support of the National Institute of Health and the National Eye Institute. Thank you very much. Have a great day.